In 2016, an age determination study published in Science revealed an extreme biological timeline. Using radiocarbon dating on eye lens proteins, researchers placed the age of one single Greenland shark at 392 plus or minus 120 years. That measurement makes the Greenland shark the longest-lived vertebrate known to science. The estimated maximum lifespan for the species stretches between 272 and 512 years. Yet, despite enduring for centuries, almost every adult Greenland shark navigates the ocean functionally blind. Their eyes are frequently colonized by a parasitic copepod called Omatocoida elongata, which anchors itself directly to the cornea. The presence of this parasite causes severe corneal ulceration, mineralization, and edema, stripping the adult sharks of near-total visual clarity. The survival of this species does not rely on visual acuity or swift predatory agility. It depends on an extreme physical adaptation to a dark, unhurried existence. They inhabit the dark, freezing waters of the Arctic and North Atlantic, operating in temperatures that hover strictly between -1.1 and 7.4 degrees Celsius. Their typical range sits between 100 and 1,200 meters below the surface, though they have been documented at far greater pressures, including an observation at 2,200 meters near the wreck of the SS Central America. In this cold, energy is strictly conserved. The Greenland shark's average cruising speed is roughly 0.34 meters per second, about 1.2 kilometers per hour, making it the slowest fish of comparable size. Its metabolism moves at such a glacial pace that the shark grows at a rate of only 0.5 to 1 centimeter per year. Over enough centuries, that slow accumulation yields massive animals. Adults typically measure 4 to 5 meters in length, with the largest confirmed specimen recorded at 6.4 meters and weighing approximately 1,023 kilograms. The freezing high-pressure environment forces a biological pace completely disconnected from human measures of time. To measure an organism that outlives human history, researchers had to find a physical record hidden within the shark's anatomy. They found it in the crystalline proteins of the islands. Because these specific proteins are laid down at birth and never replaced by the body, they serve as an untouched biological time capsule. By isolating carbon-14 trapped within the eye lenses of 28 sharks killed as bycatch, the team reconstructed their life histories. The data revealed an immense delay. A female must reach 4.19 meters in length before reaching sexual maturity, a process taking roughly 150 years. Once maturity is reached, the reproductive cycle is heavily prolonged. Gestation in this species is estimated to take between 8 and 18 years. A female carries litters of up to 10 pups, each measuring 38 to 42 centimeters at birth. Across her entire multi-century lifespan, she may produce a total of 200 to 700 pups. The very extreme metabolic slowness that makes centuries of life possible also dictates a reproductive cycle highly sensitive to sudden population drops. Internally, the species relies on heavy biological fortifications. Its genome, sequenced in 2024, spans 6.45 billion base pairs and contains 81 unique genes specifically linked to DNA repair. The flesh itself functions as a chemical defense. It holds high concentrations of urea and trimethylamine and oxide, or TMAO, which metabolizes into a uremic toxin if the meat is eaten fresh. In Iceland, humans bypass this toxicity. The shark is traditionally gutted, buried in gravel, and pressed under heavy stones for 6 to 12 weeks. The fermentation process converts the urea to ammonia and causes the TMAO to drain away as liquid. The meat is then hung in the elements for a drying period of 4 to 5 months. A brown crust forms during this time, which is trimmed away before the cured flesh, known as hákarl, is served. The dish retains an intense chemical profile. Chef and food writer Anthony Bourdain famously described hákarl as the single worst, most disgusting and terrible-tasting thing. It is an extreme irony of survival. A creature genetically equipped to repair its own DNA damage and chemically saturated with toxins is still regularly pulled from the depths by humans. The Greenland shark mastered the Arctic through endurance, but that evolutionary slowness is mathematically incompatible with the speed of the modern world. Across the Arctic and North Atlantic, industrial fishing operations inadvertently pull up roughly 3,500 Greenland sharks annually as bycatch. Iceland's artisanal fisheries land roughly 25 individuals annually, while the accidental loss of 3,500 sharks to industrial fleets overwhelms localized harvests. Factoring in their biological timeline, a vertebrate requiring 150 years to replace one breeding adult cannot outbreed industrial-scale losses. Due to this deep vulnerability, the Greenland shark is officially listed as vulnerable by the International Union for Conservation of Nature. What does it mean to drive toward extinction a vertebrate whose single generation is longer than industrial fishing has existed?